Hello student. Today's question is evaluate integration e raised to 3z upon z minus pi dz over a c where c is the curve modulus of z minus 2 plus modulus of z plus 2 is equals to 6. Here we have to understood what is c first and then we have to integrate this. Okay. Now here c is modulus of z minus 2 plus modulus of z plus 2 is equals to 6. So this is the equation of ellipse. We have to compare with the standard equation. Okay. Now compare with modulus of z minus z1 plus modulus of z minus z2 is equals to 2a. Correct. Now here z1 and z2 are foci and length of major axis is equals to 2a. So this implies 2a is equals to 6 from this equation. So this implies a value is 3. Okay. And z1 is equals to 2 and z2 is equals to minus 2. Okay. Now here foci is equals to a comma 0 and we have to compare with this 2 comma 0. Correct, because this foci are z1 and z2. You can compare with ae is equals to 2 comma 0 and otherwise we have to compare minus ae comma 0 with minus 2 comma 0. Both are the same thing. So this implies ae is equals to 2. So e is equals to 2 by a, but a value is 3, so 2 by 3. So e is equals to 2 by 3, which is strictly less than 1. This proves that it is ellipse. Right? Okay. Now we have the eccentricity formula. A is square root of 1 minus b square upon a square. So this implies 2 by 3 is equals to square root of 1 minus b square upon 9. So from this we will get the b is equals to plus or minus root 5. Okay. We got the a value is 3 and b value is plus or minus root 5. So we have to write the standard equation of ellipse. So equation of ellipse is given by x square upon a square plus y square upon b square is equals to 1. So this implies x square upon 9 plus y square upon 5 is equals to 1, and this is equation of ellipse. Okay, so C is x square by 9 plus y square by 5 is equals to 1. Okay, now we have to evaluate. Now to evaluate integration C e raised to 3z upon z minus 5 dz. Okay, so here we have to use the Cauchy theorem. And what is Cauchy theorem? Cauchy's theorem. Okay, what is Cauchy theorem? If C be any simple closed curve in domain and f of z is analytic inside and on C, then integration f of z dz over C is equals to 0. right? This is Cauchy's theorem. Now, here, here, f of z is equals to e raised to 3z upon z minus 5. Okay. Now we have to prove that it is analytic function inside and on C. Now, but here there is a singular point. Okay. Now, first we have to find singular point of f of z. Okay. Now, so how to find this singular point of f of z? Just put denominator part is equals to 0. And what is denominator? Z minus pi is equals to 0. So z is equals to pi. Okay. Now, singular point are those points in which my function is not analytic. Correct. Okay. So z is equals to pi is singular point of f of z. Now we need to check that z is equals to pi, which is similar to pi comma 0 in xy plane, which lie inside or outside C. Right? Okay. Now how to check that? Now first of all, what is given equation? X square by 9 plus y square by 5 is equals to 1. Now x square by 9 plus y square by 5 is equals to 1. This is our C, right? X0, Y0 be any point. Okay. Now, if x0 square upon 9 plus y0 square upon 5, which is less than 1, this implies x0, y0 lie inside C. Okay. Now, if x0 square upon 9 plus y0 square upon 5, which is greater than 1, then x0 comma y0 lie outside C. And if x0 square upon 9 plus y0 square upon 5 is equals to 1, so this implies x0, y0 lie on C. Now, here, here, z is equals to pi, which is similar to pi comma 0, correct? So, x0 square upon 9 plus y0 square upon 5, which is equals to pi square by 9 plus 0 square by 5 is equals to pi square by 9, and it is strictly greater than 1. So this implies x0 y0, that means z is equals to pi, which is similar to pi comma 0, which lie outside C. So this implies f of z is equals to e raised to 3z upon z minus pi is analytic inside and on C. Right? Okay. Now look at the graph here. Now here there is a singular point of f of z which is pi comma 0, right? Which is lie outside the C, correct? That means in this C, my function is analytic everywhere in C, correct? And and my function is analytic on the boundary also, right? So my function is analytic on the boundary also. Okay. Now look at the Cauchy theorem. What Cauchy theorem says that if C is be any simple closed curve, in domain, and f of z is analytic inside and on C, then integration f of z dz C is equals to 0. So by Cauchy's theorem, so by Cauchy's theorem, by Cauchy's theorem, Cauchy's theorem, integration C f of z dz is equals to 0. So this implies C e raised to 3z upon z minus 5 dz is equals to 0. So this is the final answer. Okay. I hope you understood that. Thank you.